Alright everyone, this one says determine whether the lines passing through each pair of points are parallel, perpendicular, or neither. Well, in order to answer that question, we have to understand a little bit about the relationship between parallel and perpendicular lines. So let's take a look at parallel lines here for just a second. If two lines are parallel, then they have the same steepness, right? And slope measures how steep a line is. And these guys are equally steep. So it seems reasonable that they would have the same slope. Now, if you're not convinced by that, just let's eyeball it approach. You could always just take 2 points on the line and calculate the slope. Or look at it this way. The slope, remember, is the change in y over the change in x. So this has a change in y of 3. This has a change in x of 2. Now let's take 2 points on the other graph. Take that one and say that one. The change in y here is 3. The change in x there is 2. So they have, you can see, the same exact slope. So that's true of any parallel lines. Parallel lines have the same slope. Now let's look at perpendicular lines. This is a little more complicated graph because it's not quite as intuitive what's going on with perpendicular lines. These two lines are perpendicular, which means that they form a 90-degree angle. Well, we can see that the blue graph, the blue line, has a positive slope. Remember that if the graph is rising as you go left to right, it's a positive slope. This one has a negative slope because it's falling as we go left to right. And that'll always be true for perpendicular lines. One's going to have a positive slope, the other one's going to have a negative slope. So one thing we can say for sure about perpendicular lines is that they're going to have opposite signs. But it turns out we can say a little bit more than that about them. If we calculate the slope of this blue line, then it's, well, let's formula for slope, remember? y2 minus y1 over x2 minus x1. Well, we'll start with this one. This is 6 minus 1 over 6 minus a negative 3. Well, this turns into 6 minus 1, which is 5. 6 minus a negative 3 is the same as 6 plus 3. Well, 6 plus 3 is 9. So this has a slope of 5/9. Now let's look at the slope of the red line using those 2 points. So that guy has a slope of, well, the change in y will be 7 minus a negative 2 over negative 2 minus 3. So let's simplify that. 7 minus a negative 2 is the same as 7 plus 2, which is 9. Negative 2 minus 3 is negative 5. Now compare those two slopes. One's positive and one's negative. We already knew that much. But not only that, but they're reciprocals of each other. 9/5 and 5/9 are reciprocals. So they have opposite signs and they're reciprocals of each other. Well, that's true of any perpendicular lines. So any two perpendicular lines will always have these two characteristics. They have opposite signs and they're reciprocals of each other. All right, now let's go back to the original question then. Does the line made by these 2 points compare to the line made by these 2 points? Are they parallel, perpendicular, or neither? Well, let's calculate the slope. Remember, it doesn't matter which one of these is x1, y1. So we could let that be x1, y1. This be x2, y2. So if we do it like that, then the slope is 9 minus 7 over 7 minus a negative 2. 9 minus 7 is going to be 2. This is the same as 7 plus 2, so it's 9. So it's 2/9. That's the slope of the line that goes through these 2 points. Now let's take these. And again, we'll just go in the same order. x1, y1, x2, y2 here. So negative 5 minus a negative 7. Well, we got to really watch our signs here. This guy minus that guy. Negative 5 minus a negative 7. And then the change in x will be 2 minus a negative 7. All right, so this is negative 5. I'm going to write this down. It's so messy. Negative 5 plus 7. And down here I'm going to have 2 plus 7. Negative 5 plus 7, well, that's a positive 2. 7 plus 2 is 9. All right, 2 ninths and 2 ninths. So the lines are going to be parallel lines.